thing I asked you to identify was what, the zeros? And what did everybody do to find those zeros?
Zero product property.
Now, you are correct that we, hey, who left their slides up here? You go grab your slides. I want to caution you because I actually only see, actually I'm looking around the room, I don't see anyone who properly used the zero product property. You may have gotten the right answer at the end, but I haven't seen anyone who actually used the zero product property correctly. Remember, how do you have a zero product property without a product of zero? You guys said the g of x equal to 0. So like the first thing that we should have done, I'm going to come back and talk about this in a second, is before we can set each factor equal to 0 properly, you got to set the function equal to 0. I know that it sounds goofy, but it actually matters mathematically long term. So, not a significant procedural error, but without setting that equation equal to 0, you can't actually do a zero product property. Take the time to set the equation equal to 0. Now I can use the zero product property. And a lot of us did this very well. We set the equation equal to 0. We used inverses to solve our equations. I'm going to come back and talk about some of these things a little bit later. Now, one thing I want to caution, because I saw this mistake. By the way, does anyone actually, let me ask this, does anyone have a question about solving these equations? Because from what I saw, we all did it, and we did it well, so I wasn't going to talk about that too much. We're good on the zero product property, solving it from there. Okay, so here's the word of caution that I want to provide. So if you're in the Queens, if you could move, maybe even the Jacks, you probably can't see the TV from where you are. Jaquel, Maddie. It might be hard to see from where you are. If you can't see the TV, I do want you to come over here. Because I want to caution, like, I get this mistake, but it's a mistake that's avoidable if we slow down and we pay attention to the details. One of the most common mistakes students make when solving an equation using inverses is right here. So we got, it's right there. We got the equation 2 equals negative x, right? And we're trying to solve for x, and so what happened here?
You can't divide. You're supposed to divide by negative, not just.
So here's one thing I want to caution, because like the first instinct is you can't do that for some of us. And I will say this, mathematically, what happened here is perfectly legal. It is legal, because what happened to one side happened to the other, right? But the common mistake, and so I will agree that we probably shouldn't divide by 2, but it is mathematically legal to do that. As long as I use the property of equality. What I do one side, I do to the other, totally fine. But what usually happens for students is they then write something like this equation. But if we actually pay attention to what's happening, this is what I want you to think through. What's 2 divided by 2?
1.
Not x, it's 1, right? And then negative x divided by 2 is negative x divided by 2. This is completely legal. Again, not what I would do. If I wanted to solve the equation from here, because I used the property of equality, I could. We just have to pay attention and be careful about the fact that I did not get x equals. Notice, I could multiply by negative 2. Because what's 2 divided by 2? 1. And what's a negative times a negative? A positive. So could I do this to solve for x? 100%. Notice that gives me the same exact 0 that if we did it over here, okay? So a couple of words of caution with that is, make sure that you're actually paying attention to what's happening when you apply those operations. If you don't think it through, it's really easy to make this mistake. And that's fine, but think through that detail. The other thing I would point out is this. No, this is what I want to talk about over here. Remember, the whole thing is that we are trying to create what? Zeros. So if I were to substitute negative 1/2 into here, is that going to create a 0?
No.
So take the time and like pay attention to those details. Now if I put a negative 2 here, what's the opposite of negative 2? Positive 2. What's a positive 2 minus 2?
0.
So it doesn't matter what anything else is. What's 0 times anything? 0. So keep in mind what we're trying to do is create those zeros, because it doesn't matter of what anything else is, if I've created a 0, when I multiply by 0, what do I get?
0.
0. That's a zero product property. And then I had another mistake over here that's an awesome mistake, but it's one that I do want to caution against. Originally, I don't think it's still up there, which is totally fine. Originally, what I saw in this group was, which is great. But I want you to notice, what got substituted in for x right here? What got substituted in for x right here? And what got substituted in for x right here? And the reasoning being, I think, because you just put your zeros in, right? But here's the thing. If I say x equals -2, what does x equal? So it needs to just be -2 all the way through there, okay? If I say x equals -3, what is x every single time? 3, right? And so make sure you pay attention to that detail, because we're not going to change what the x is at each point, right? We're just going to have the beauty that it doesn't matter what this is. It doesn't matter what this is, because what's -3 plus 3? 0. And 0 times anything is 0. It doesn't matter, up here it doesn't, no, which one is it? Up here, it does not matter what this is, because what's -2 plus 2? 0. And then this was also a 0. So notice, I've said this before, how many of those factors have to be 0?
1 each.
I've never said 1. I said at least 1. Why is that detail of at least 1 important? Look up here.
That's all you need, right?
Yeah, but could it be more than 1? Because that's what kind of root there, that -2. Right. So remember, the zero product property doesn't say that one factor is 0. It says at least one factor is 0. Because if I multiply by 2 zeros, what do I still get? Well, just 0, right? What happens if I have...
Still 0, right?
That's still going to be 0, isn't it?
Yep.
0.
Right? It doesn't matter how many zeros, it just has to be at least 1. We multiply by at least 1 0, that product is 0. Okay? What questions do you have about zeros and multiplicity? By the way, that meant that we had what multiplicity for x equals -2?
2.
Multiplicity of 2. So it's a double root, right? Remember, the multiplicity just means that that 0 happens more than once. You cannot always see it right from the factor. You have to set it equal to 0 and find your roots. Yes,
So
Vicari.
like, if there's like 3 x equals -1, we say multiplicity of -1.
3, say that one more time.
If there was like 3 x's that equal -1, would we say multiplicity of
Yeah.
1, -1?
So if you solve each of these right here, you will get x equals -1. And so you just say x equals -1 with a multiplicity of 3.
Why you put -1 for x plus 1?
No way.
What's
Okay.
negative
Oh, I
1
remember
plus
it's
1?
factors, so you're doing the opposite.
That's part of it as well. Remember, it needs to make a 0. If it was a positive 1, what's 1 plus 1? 2.
Yeah, I understand. It's factors, so you're doing the opposite way, right?
Alright.
I got you.
Now be careful, it's not just that, because you'll notice with this -1, it was still -1. That's because there's an opposite here too. Set equal to 0 and solve. Alright, that's zeros and multiplicity. Ooh, someone actually started a sketch of the graph. Sweet. Crushing it, Taj. I appreciate you, sir.
Come on, you move it.
Both beyond. Now I gotta find some chalk.
Did you call you?
What?
Move it, baby.
Yeah.
Well,
The what color is it?
now which one is
Positive.
No, that's right.
We'll talk about it in a second. Ask your question when we get to that. So, ladies and gentlemen, I know it's hard to see right here, but I'm gonna make it a little bit darker so you can see this. So this was not asked for. Hey, right here, Ricardo, it helps if you actually look at the board. So I didn't actually ask you to graph this, but this is gonna help with our domain and range. You'll notice that we have how many factors graphed here?
3.
3, right? Because this is the
Double root.
x plus 3, is that
Oh,
right?
never mind, my fault.
So y equals x plus 3 right here. This is the y equals x plus 2 right here.
Yeah, they do.
And then this is the negative x minus 2. Notice y-intercept and a slope of negative 1. You can also find the zeros. And so, Taj, how did you get that these were positive right here? It's a lovely sound.
You put your hand over a little bit. Right there. The negative times the negative.
Oh, I got you right here. So notice negative, negative, and positive. And if I have two negatives, that becomes what? Positive. And so you came through, and notice it goes through here, and that should make sense because that has a multiplicity of 1. That's a single root. Then it comes back up to the next 0. But what is that next 0? It's a double root, multiplicity of 2. So it's got a what? Bounce. Sweet.
But it's 2 minus something.
Well, there's two. Remember, that's from the 3 factors. But what of positives and negatives? But we're talking about this 0 right here. How many zeros do we have? Well, only that one line goes through, right? So remember, one thing I'll point out is this right here is this section, not the 0. One line goes through there, so it's 1, 0. You good with that? And so there's our sketch of that function. So domain, I think everybody that I saw put negative infinity to infinity. Why?
What's up with baby there?
What's some info that I can put with that negative infinity to infinity to explain that domain? What's some information I could put with this negative infinity to explain that domain?
Minimum,
Minimum what?
minimum X.
Y or X.
Remember, domain is all about the
X.
x. Infinity is the,
Minimum X.
Maximum.
Maximum.
remember, if I hear domain, I'm only thinking about x. If I hear domain, I'm only thinking about x, and it's minimum to maximum. So, does it ever quit going left?
No.
No, Mr. Kenny, thank you. Does it ever quit going right? No. So minimum to maximum. What about my range here? What do I need for my range?
Minimum 8.
So I need minimum
Y.
y. So does it ever quit going down?
No.
It continues.
And then what's my maximum y?
Maximum Y.
What is it?
Maximum.
But what is it?
Positive infinity.
Okay, looking around the room, not many of us got our extrema.
How about it?
Say again.
We gotta do the relative, what's it called?
We gotta do relative max and relative min. I will say this, can anyone look at the graph and see one of the relative extrema?
So like one of them would be like 0.
One of them's a what?
One of them would be 0, right?
What do you mean by that? Can you explain?
Because of the double root and.
So this double root right here, what is that also gonna be called?
0.
What type of max? There's a word that goes before it.
Relative.
Relative. Because remember, is that the highest point for the entire function?
No.
No, I got big stuff way over here, right? But that's the highest for its area. Remember, that's when it stops what?
Going up.
So what's the mathematical term? Stops increasing and starts to decrease. So the relative maximum, you said is 0 at what x value? What's that x value that 0 is located
And why
at?
we gotta add value? I mean, why we gotta add sign?
No, you said X.
Well, I'm gonna-
2.
At x equals -2. You can write it as a point, okay? The x is -2, the y is 0. Really, a maximum value, though, is the output, the 0, and it's located at the x value. So you can write it either of these ways.
Real.
So you can either write it as the point, or you can write relative maximum value of 0 at x equals -2. But here's the thing, can you find that maximum just looking at it, or that minimum just looking at it?
You have like a, you do a calculator.
Yeah. Hey guys, pick up a calculator, graph the function, and let's find the minimum using the calculator. Don't make it harder than it has to be.
Don't make it weird, don't make it weird. Mr. Kitty, come here.
No.
Yeah, Mr. Kitty.
Miss Kid, I ain't gonna please.
Tell him that he's out.
You literally just heard 2 different people ask me to come to them, right?
No, well, I actually want you to take the pay attention. I want you to pay attention. That's
Tell
what
him that
I'm
he's outside of his
I
mouth.
do pay attention to that.
Tell him.
But there.
My
My
Justice, you starting to understand it?
Okay.
Good. Me too. That ain't a lot of exercise.
Good, I'll learn to run.
My
Damn, my shit is true.
I'm satisfied.
The function. That we went with. The negative x plus minus 2 times
Let me tell you.
x plus 3 times x plus 2. Guys, negative x minus 2 times x plus 3 times x plus 2 is the g of x that we all have written around the room, right here.
Oh, bring me one too.
Alright? That function. Yes, ma'am. Hit escape. And go to menu. And just go for Windows Zoom and use Zoom.
Mr. Kenny Bailey, you take my
Do what? I think I did.
Wait, so what we supposed to be grabbing?
Mr. King, I always wonder, what they for? Mr. King, what they for?
What's what for?
Talking about that piece of the calculator.
To graph the function.
No, I think I did mine wrong.
So, negative x minus 2 times x plus 3 times x plus 2.
Correct.
Okay?
Yo.
Now,
It's only
Right here.
It's only 12:20.
this is what it should look like. You'll notice it's a really small minimum here because the roots are so close to each other. That's why you have to be careful finding your minimum. So when I go to, what do I do to find the minimum on the calculator? Menu. And then?
Window.
Analyze.
Remember, I'm going to analyze the graph for a minimum. Please note, lower bound, I got to go to the left. And when I get to that minimum, you see how that point stops? Right? So the point is moving, then the point stops. If I go too far, it keeps moving again. You got to make sure you're right around the minimum, and there it is. Graph the function.
Cornball ass man. Wait, we looking for the minimum or the maximum?
Minimum. We already got it.
Remember, we already have that maximum, it's that double root.
Oh, I got negative.
Pop it, pop it.
I got negative 0.148.
That's what I got too.
Oh,
That's that I got.
James.
Pop it, pop it.
Okay.
yes.
Mr. Kenny.
No.
Okay.
Something's wrong with you.
No, I just want to be sure I understand what I'm
I
doing.
didn't take my medicine today.
So you should have that minimum in there.
Huh? You want to talk to me? I was saying, you want to talk to me?
No.
No.
You looking at me, that's all that.
Turn around. You want to talk to me? Turn around. Escape this right there. Take it out.
Okay. So remember, when it comes to your demonstrate understandings, I've given you feedback, I've written questions, I've talked about things, and some of it's very, not some of it, a lot of it's very personalized based on the things that I am seeing. So at this point, with the feedback you've been given, what questions do you need to ask? We're going to go in order. So if there's a question you need to ask about 1 or 2, please let me know. I will say this, 1 and 2 should be much easier after the last few days. Hopefully.
Alright.
Oh, you too much.
But it is still 3 roots, right?
Huh?
It is still 3.
Number 1,
Yeah.
there are 3 roots, yes sir.
Okay.
Because it's about the evidence on this one. Notice, we started with how many roots?
You don't talk about them.
We started with 2, but then what do we do to it?
We got it.
So dilated, we multiplied it by x minus 3. So we had 2 roots and then we created another one. Yes, ma'am.
So you y'all said like X minus 3?
So we dilated by x
Yeah, I
minus 3.
know, so since you say that means it's gonna be
Wait, how?
0, right, because it has a 3.
Well, how many zeros is it going to be? Hold on. Remember, that's my f of x, right? and then I'm creating
Hey, let me touch your beard.
one more zero, it is the
This one.
0x equals 3, but how many is that?
Oh,
It's the number 3, but sorry, I'm just talking about this one. How many is this one?
One.
Just
One.
one. I originally had
Two.
2, I now have a
Third.
third. So what degree is it?
Three.
Third degree. That's it.
I got
So it
that
was
right.
originally
I got
2,
that right.
I dilated it by a linear and created a third. But,
Makes you different options.
how many x-intercepts does that function actually have?
2,
Why does it only have 2?
because it's like on two zeros, because x plus 5.
We just said, well,
It's gonna be a double.
there we go. Notice, how many different zeros do I have?
Here you go.
Guys, how many different zeros do I have? 2. So how many x-intercepts do I have? 2.
Yeah.
Right? There were 3 zeros total, but one of them is a double.
Same, right?
One of them is the same, it is a double root.
Right.
Okay, we're about to go to lunch. When we come back from lunch, we're gonna finish this up quickly so we can do. So, this is the answer that we should have. There's no justification for it, but how do we know that that's what the f of x times g of x would look like?
Yeah, how we know?
Yeah,
So boom. Like, you know, we did that.
oh,
Split up 1. The negative times negative.
okay.
You not
Guys.
gonna-
Negative times negative, what does it give me?
Pause.
Zoomed in, yo.
Right, J Mike?
Yeah.
I
Okay.
gotta be zoomed out, you know.
Right here. Good. Positive times,
Negative. Pause. I mean negative.
positive times negative is negative. Positive times positive,
Pause.
we got single roots all the way through, it's going through those roots. That's it. Anybody need me to add any clarifying information?
No,
So
sir.
Amber knows it's just multiplying the positives and negatives of the factors, just like we've been
That's
doing.
number 3.
That's number
Yeah.
3.
Can you do number 6, please? Wrong.
Who right here?
We gonna get that OG.
Do we need to talk about 4 or 5? All right, there's not a 5 there.
It's,
4?
Yeah, 4.
What about 4?
It's 4.
4 game.
It's 4.
It's 4.
Hey guys, has anything changed from the last problem?
No.
What do I need to mark first?
Your x intercept. I mean your x values.
My zeros.
Yeah, your 0.
Now, what should I notice about this 0 right here?
Multiplicity of 2.
It's got a multiplicity of 2, right?
Yep.
Notice we got, it's a double root, yes.
I don't know where to put the point.
Remember, the zeros, right here, that 0
Oh.
will be a 0 in my dilated function. That 0 will be a 0 in my dilated function. So when I multiply, because remember, the whole idea is I'm multiplying these outputs. This output right here is 6. I don't even know what this output actually is. It's some kind of negative, but if I multiply by 0, what do I get?
0.
So that's a 0 for my dilated function. I'm multiplying those outputs. So I gotta look to the left, just like before. And my guess is, the biggest issue anyone had here was they did a positive times a negative, but what's the issue with that? Or what? It's not, but like, why is that a
You
problem?
have 3 factors.
Say it again. How many factors we got? What's up, Cameron?
Can you run my fast?
No.
No, I went to the
Yeah,
bathroom.
you just had your face all up in the
We gotta do
camera.
that class in 5 minutes. Cameron. Where's- Cameron, that's your first. A what? Why would I have a Ziploc bag and shell them? Yeah, I bring them in reusable containers.
You got a map thing?
Alright, so Todd, what were we saying the issue is? We have how many factors? 3, and how many positives or negatives do I have? I only have 2. What's my third one then? But where do you see in that?
You don't see that graph.
Yeah, will this line stop?
Sorry, that was me. She picked up
Thanks, George.
that here.
No, this is kind
Get on my camera spot.
my camera.
Move, Corey, get out the way.
of, yo, guys. Preston,
Just sit out.
wait,
Okay.
So I thought we talked that you were gonna make sure you grab a seat and take notes as we go over this.
Oh, I ain't know what
During
that
the
was.
demonstration exam.
My bad.
Okay. Yes, apparently doesn't need to take notes.
No,
So,
not
third
after, not
factor has
after
what
all
type of
that.
values down here? Negative, and what's a positive times a negative times a negative? So, I start at this 0, and it's positive, all the way to the left and up. Here you go, Tyler. Now I gotta look in between the zeros. We can more clearly see here, how many factors do we have? 3. What are they? Positive, positive, and 3 positives? Alright, what's positive times positive times positive?
Negative, negative.
That's positive.
Positive times
That's a
present?
negative, that's a negative.
Mr. Kenny?
Negative.
How is that a negative mark?
Positive.
Positive times,
A positive times a positive?
Times a positive?
Hey, wait, don't
They
write
said
this down,
negative.
guys.
Positive
Pause.
times positive times negative.
There's
No,
shooting.
positive times
Somebody
positive
can't
times
hear.
positive.
Okay, I
Look,
said
back
negative.
up, back up.
Shorty is negative.
I need y'all to think about this again. Y'all told me I have 3 positives, right?
No.
And if I multiply 3, so hold on to that, thank you.
I mean,
If I have 3 positives and I multiply it, I get a what? Positive. But that would require this to bounce. Is that a double root
Oh,
for it
no.
to bounce?
is this
Yes.
No.
No.
Oh my god.
Guys, I don't have 3 positives. Positive, positive, and
Negative.
negative.
That's negative.
And so this should be negative. Notice it's a single root that we go through. Now that is a double root there, so what should happen?
It bounce.
It should bounce. Let's check. Positive, positive, negative. What's that give me?
Negative.
Negative. So does it bounce?
Yeah.
What type of function do we have in this case?
Cubic.
Cubic,
Why is it cubic?
because it bounces.
It got 3 roots.
It's got 3 zeros. Also,
3 0, yeah.
doesn't that look like the shape of a cubic function that we've
Yeah.
seen time and time again?
Yeah.
Right? It's got the same shape of a cubic. It's got 3 zeros. Those are things we want to pay attention to here. Where to put the... Number 5 is what we've done for the last few days. Remember, the reason we were able to multiply those factors on the last 2 was because we had the graphs of those factors. Do I have the graph of every factor on this one?
No.
Is that right? What's the answer? Come on.
Oh.
Do you know the question I asked?
No.
It's hard to learn if we don't even know the question that's being asked.
Mmm.
I asked for this number 5 here, do we have the graph of
Should've.
every factor? I've got f of x graphed.
You gotta find 0 part of it, right?
No?
0, I mean.
No?
It's nothing but.
I need what graph? Right, I'm trying to dilate this by 2x minus 2. I need to graph y equals 2x minus 2.
It is 0 part of it, right?
I don't need to.
No,
Do I have to if I want
That's why you made
Why would you
me
use
Oh,
that?
back up.
That's the
Listen.
question, you don't need to.
Ricard, you can set it equal to 0 to find a 0. But can you use zero product property if you don't even have a product?
No.
So like, if you wanted to, you could have done x squared minus x minus 6, and then multiplied it by 2x minus 2 because you're dilating. But you already have this function, so you don't need to really actually sweat this. So if you want to use zero product property now you can, because you have a product of 0, but that was more work than you had to do. Now this does help me find
Yeah.
my 0. What is my 0?
1.
X equals 1. Do we know anything else about y equals 2x minus 2?
Well, 2x minus 2.
Yeah, y
It
equals
gets
2x.
you 0.
We just found the 0. Do we know anything else about this function?
Well, the y-intercept is -2.
Y-intercept is negative 2. And this should make sense because what's my slope? It's going up 2 to the,
Right.
up 1, 2, to the right, 1. We see from the x and y intercept that same exact slope. So you didn't have to use the slope if you just have your x and y intercepts. Now, we can easily sketch what this function looks like. So we should have done. All I did was I looked at a positive times a negative, negative times negative, positive times negative, etc. Just found my positives and my negatives.
I had my point in,
Say it again, Taj.
I had my point in the line.
Gotcha. Do you see how to fix it though?
Yeah.
So was everything else right?
Yeah,
So what did you earn on that?
I got D.
D. So you have developing evidence, right? Like remember, that's why I want you to show me what you're thinking and how you're approaching it. Because
Oh, you got me
I
there
would
too.
assume, Taj, for the most part, it doesn't look anything like what I have up here.
It does, it's just the point is wrong button.
Straight OG.
I guess it's somewhat similar.
Jeff
But-
Fox's, you know.
Oh, no, so you actually made two mistakes.
You know what I'm talking about?
That's why it's
You get
easy
the
to look.
Yeah, I did.
You actually did have the right graph.
They like to do it again.
Or somewhat right to look. What's the positive?
Come on.
I ain't sick though, my temperature is good.
Positive is.
You get the cuties.
I ain't got no.
Started either.
I went to
So that's why it's the
on
easy.
Monday, I was sick.
Alright. Questions on 5?
It's pepper.
No.
I need
Okay. Was that the last question?
number 6, right?
Yeah,
Oh, what degree is it? Yeah.
Third degree.
Third degree. How do you know it's third degree?
Polynomials are functions that has 3 roots.
So cubic functions,
Cubic functions have
or
3
third
roots.
degree polynomials have how many roots?
3.
3. How many roots does this have?
3.
I would also point out that you can note that like this here, we have a quadratic times a linear. And what type of function do we always get from a quadratic times a linear?
Well, you tell again?
A quadratic times a linear
Cubic.
always gave us a cubic. And that's because it had 3 roots, right?
It's quadratic.
But it's a cubic, has 3 roots. Okay? Alright. Where's you're just good, you didn't need writing notes? Okay. Because you know you're not even on the same page that we're on, right?
Who would do this, man?
It's hard to learn if you're not engaging in the process.
What, bro?
So,
You want to do this.
Real.
Um,
Attention.
one thing I will remind you, that's why I have this right here. Why did we actually know that this was a third degree looking right here?
The root.
The number of roots?
The
So
linear
what's the
already get
major
one.
idea in algebra that connects the number of roots or zeros to the degree?
Huh?
Major idea that connects the roots, number of roots or number of zeros to the degree.
Oh.
Sorry. It's pretty fundamental to algebra. Guys, y'all heard me talk about the fundamental theorem of algebra for every day for the last like week plus.
Let me write this
That's
down.
going to be on your assessments. I'm telling you that right here and right now. The fundamental theorem of algebra states that any polynomial equation of degree n must have how many roots? N roots. So if it's third degree, it has 3. If it's third degree, it has 3 roots. If it has 3 roots, it is third degree. If it has 7 roots, it's going to be 7th degree. So that's how we know what type of function it is building it off of the number of roots.
Hey, hold on though, OG. I need you to leave it. I don't write it down.
I mean, you could summarize it by just simply saying the degree matches the number of roots.
Oh,
On what?
Degree matches number of roots. That's a more plain way to say it. This is the mathy way to say it.
We want to write that down?
Huh?
We want to write that?
the number of-
We want to write on, like, which paper? Domain and range function?
Ooh, well, it's about degree, right?
Okay.
So it's one of the earlier ones that was about degree. You can also just put degree or put fundamental theorem of algebra down and circle it and make sure you write it down. But we're gonna apply it here. So we don't have time to talk about this right now, but I do want to point this out. When I look at this g of x right here, what degree is g of x? So just looking at the board, what
It's
degree is
good,
g
it's
of
good
x?
degree.
It's fifth degree. How do we know it's fifth degree?
Because that's the highest power.
That's the highest power, right? Highest power is 5. So how many zeros should it have?
5.
Does it have 5 zeros?
Yes.
Yo.
Okay, that's all I want us to see. Now, I'm going to make up one really quickly, and I want us to talk about a really quick detail with it. Something like this could, and I don't know for sure on this one, something like this could look like this.
If it, yep.
Okay? So, I should have looked at this. So looking at this polynomial, how many zeros should this polynomial have?
4.
It should have 4, right? How do we know 4?
Because it's the
Because
highest.
it's the
Highest power, so it's 4th degree, so it should have 4 zeros.
But it got 2.
But it only has how many?
2.
You sure? It only has 2.
Yeah, it got 2 zeros, don't
What
it?
problem is this?
I do only see, I made this one up to illustrate.
Down page 8. On page 8.
I'm making up a problem to illustrate a point.
Oh, you're just making up on it.
There are 4 zeros.
Dang, how is there 4 zeros?
Well, see,
They're probably gonna be imaginary or something like that.
So look, I can't see them, but here's the thing. How many real zeros do I have?
2,
2. But I have to have how many zeros?
4.
So what are the other 2 gonna have to be?
Imaginary.
Imaginary.
But we
I
need
can't
to
see them,
imaginary.
they're imaginary zeros.
Because you can't see them, Bakari. It's not that hard. If you don't see them, that means that they don't exist. They imaginary.
It's not that they don't exist, they're just not on the real number system.
Mr. King, you don't see the same thing. Imaginary.
So we're finna go back to the number I.
So we are going to use that sum, okay? J Mike, what about the number I do you hate?
Oh, no.
Why are you acting like I shot your puppy or something? Like, it's just a number.
I'm at
Okay. Wait, what did you say?
I do what you look.
You're funny.
Wait, still no way.
Oh, dang it.
Alright, right here. Listen, the only thing that we need to recognize is this. We know this has how many zeros?
4.
It has to have 4. That's the fundamental theorem of algebra. I can see how many.
2.
So if there's 2 real, what do the other 2 have to be?
Imaginary.
Okay?
But where would the 2 imaginary actually come from, though?
We don't see them. We don't know. We
Big
have to
boy.
solve the equation,
beta.
Bakari. If we haven't solved the equation, we don't know where they are. We just know that they're 2 imaginary. You can actually construct functions with imaginary. For example, notice, what degree would this function be?
What?
3. Oh. no.
It'd be 4th degree.
Why do you think 4th degree?
Well, cause like they're like,
Yeah, because it's in factor.
It's in factored form.
and you gonna have to use zero product property as well.
I mean, yeah, but like, this is linear, right? So how many zeros does this have?
1,
This right here,
1.
1,
1.
You're the one that-
How many zeros does this have?
1. They're gonna be imaginary 2 on would be.
But notice, these 2 are gonna be what?
Imaginary.
That's all we even need to recognize. I can construct one that simply by writing in factored form and putting imaginary numbers in there. That's all it is. And we're actually about to use this, not the imaginary part, but we're about to use this on page, what is this? 176 from the textbook. So if you get out page 176 from the textbook, this is the last thing for this unit. We've already done this actually. the same time.
Oh my God, that's taking Turner's coffee and sneezing. Gotta get out of here.
176?
No.
Now, I'm gonna just do this, I'm gonna give slightly different instructions. Page 177,
Okay, thank you.
B. I want you to find the standard form and graph the function. Okay? So this is page 177. I'm gonna let you use what I know we have already done in class. And don't do A yet. I want you to go with your with your group to your vertical surfaces to, and this again, it's just B here. I want you to find the standard form, and I want you to graph that function. X plus 2 times 5x plus 1. So let's find our zeros.
What's that on?
Let's find our standard
It's on the
form.
board.
Page 177.
She's raising on both.
Oh, it's on B, I see it.
Yeah.
Yeah.
Let's go. Let's get up. I'm trying to make sure y'all are good to go. Eyes and ears.
Oh, bro, can I admit me?
Alright. So, first things first.
Look, bro. Look,
Hey,
I'm doing my
Maddie.
work. Look at my
Hey,
work
Carter.
right here, bro.
I need y'all to pay attention. Just remember, if I'm trying to go to standard form from factored form, what are you going to use?
Area
The
model.
area model, right? That's it. I'm going to use the area model. Be careful. Make sure if you're going to do it this way, you put parentheses around it. Otherwise, there's no reason to distribute. But that area model is excellent. Taj, you and I talked about this. You asked if you got it right, correct? With 5x squared plus 11x plus 2 is what I see all around the room. What did you do to check yourself so I didn't just tell you that you were right?
And put me in the calculator to see if you put both of them in actually.
When you say put them in, what do you mean?
I'm on my dream.
You use the calculator to graph them, right? Guys, take the time to graph your factored form, graph your standard form, see if they're equivalent. But, look around the room, what's our plan to try to graph this function? Because I saw some of us trying to use the calculator and we were getting things wrong, even using the calculator because we weren't paying attention to
Can't name it.
details.
Could be recording.
I want you to be able to graph this. What can we do to graph this function? I think someone asked, how do we graph it from standard form? And what did I tell you? I wouldn't graph it from standard form. You could. Tosh. Yeah, it's true. But how about this?
What you doing on this Friday, Mr. King?
Teaching.
He ain't finna be teaching tomorrow.
McKenna, these things weren't gonna be here Friday because you got some milk.
Oh, I would have liked this.
I wish you could be up at gym on Friday.
I got a question.
Come on.
There it is. Done.
I gotta step out real quick.
How did you do that?
Bro, get back.
Hey guys, could I graph the factors? And then use those factors to figure out what the function
I'm
looks
saying,
like?
Mr. Kenny, can you tell
That's
us
what I
if you
did.
different by my camera?
That's what this whole unit's been about, right? Sketching, using the sketches or using the graphs of the factors to figure out what the dilated function looks like. Don't make it harder than that. There's a reason why I've built you up this way from the beginning, where we multiplied the positives and negatives. Notice, what's a negative times a negative? So to the left of that zero, I know this function has positive values. In between these two zeros, what's a positive times a negative? Negative. So in between the zeros, I've got negative values. To the right of this zero, what's a positive times a positive? A positive. Now, we'll point this out. What I also did quickly without showing is I did set this in, end up setting this equal to 0. And some of us were asking, hey, Mr. Kinney, can I use the quadratic formula? And guess what? You could. But isn't it easier to use the zero product property than try to use the quadratic formula? 5x plus 1 equals 0 is what that. Zero product property is way easier than the quadratic formula. So can you? Yes. Would I do that?
Yep, I would do that.
All Chinese food.
I would never use a quadratic formula if I could use the zero product property. Right? I asked you to get to the standard form. Hey y'all. All right. Time to learn something. Okay, so sorry, I was trying to think of what I wanted to do next. No, I do actually want to do that. So right here, we need to talk about A real quick. Whoa. Use your name?
Just guard. What am I afraid of? Whoa.
Right here.
135.
What's the issue this time?
There's three factors, three.
No.
They were like 4 zeros, wasn't it?
Say again.
Maybe 5.
So, guys, I want us to brainstorm together. Preston,
Yeah.
eyes and ears. What's the issue with this? You need this sheet as well? Yeah. Well, if I want, is it going to give me imaginary? No, I can set this equal to 0 and I would get real zeros, right? What I'm asking is, what do I need to do to go to standard form?
The area model? No.
Right, so how am I going to do that with my area model? You know, that sounds like it might actually work. Please notice, if you try to do more than 2 at a time, how many sides do you really have? You only have 2. When you try to find the area of something, isn't it just the base times the height?
Yes.
So when you have more than 2 factors,
That's different.
how many are you going to do at a time? 2 at a time. Do you think it matters which 2 it is? Hey Preston, it helps to have eyes and ears up here. Maddie, I need eyes and ears up here. Bakari?
I
Eyes and ears up here.
apologize, I apologize.
Okay, I'm going to use a simple set of numbers to illustrate this. What's 2 times 3?
6,
And what's 6 times 5?
30.
Okay. What's 3 times 5?
Brought my camera.
And what's 2 times 15?
Get back.
And then what's 2 times 5?
No, son.
And 3 times 10?
30.
So does it matter which 2 I do first?
No.
No. But notice you can only do how many at a time actually? 2. When you multiply, how many factors can you multiply at a time? 2.
Now I
So I'm
gotta
just
get my
going to
lip.
start with my x plus 2 and my negative 3x plus 2. Okay? And by the way, Makaria, we multiplying or we adding?
We're multiplying.
We're multiplying,
Get a little bit.
I
Get my mind
I've got
right.
2x's being multiplied. Negative 6x plus 2x plus 4. Are there any like terms that I could now add?
2x and a negative 6x.
2x and a negative 6x. Now, we need to notice I'm not done because that's only these first 2. What do I still need? 2x plus 1. Say again. Okay. Put this one into here.
They just broke your heart.
Hey, do you hear Kennedy asking a question?
That was Jemima said that.
Oh, car.
Yeah, I don't care. Kennedy, what's your question? Yeah.
Is everybody cool?
Right. Well, so we can do, and that's why I actually like this area model because now I just make one side longer, and now I can put 3 numbers in. This is why I teach the area model over other strategies, because now I just make a bigger box. So negative 6x cubed minus 8x squared plus 8x minus 3x squared minus 4x and plus 4.
Well, I ain't know we could do that table for that graphic.
Alright. Miss Pam, can you please be sure to upload this to me?
No.
Okay, sarcastic.
You're right.
All right. I've got 2 minutes. I need to make this clear. I'll leave this up here so you can take a picture or write down if you want.
I'll look at it.
Tomorrow, you have 2 options when it comes to class, and I will make these instructions very clear. You will either work on Mathia, which I can see what you do on Mathia the entire time. When I say work on Mathia, not something new, Chelsea is the only person in this classroom who has finished all of the Mathia assignments that
No,
I've given.
the trauma art.
Ain't
So-
the other one?
So the unit on solving